This is the video solution of XM01 Advanced Data Analysis, the prototype XM. Okay, we start at XM. You should go to ubz01fst courses XM Coletti with a folder with your name and find the XM files. In this case, only insurance.rdata. Here, if you're doing the XM at home just for training, you find the file and you just copy it to your desktop. We are pretending in this video that this one will be your desktop. On your desktop, I imagine that you have also HeidiSQL, otherwise I don't see how can you do the MySQL exercise. Another good idea is to have the XM printed, especially because you will need this thing here, for example. Okay, let's start. So connect to Alcro inf unibz.it MySQL server, blah blah blah. So we open HeidiSQL. You should see something similar. I have my own one. Okay, let me see. Okay, I open directly Northern 2003. This is my database. Build a query that shows the companies supplying more than one product. So the query involves products and suppliers. Okay, it should count the product, so it's a summary query. Let's start building a non-summary query first. So select. We need from table suppliers, as written here, company name and address. Company name and address. From the joining of suppliers in join with products on suppliers, supplier ID. If you look here, it's evident what is the joining. Equal products dot supplier ID. Okay, so currently we display the list of suppliers. They appear 3 times because they supply 3 products. Now we must put a condition. Okay, let's see. It's a summary query, so we need to count the product. So first of all, I will count the product right here. Count asterisk group by. You can group by supplier ID or company name. It's the same thing. Really, the same thing. Let's group by company name. Okay, this one displays the company, the address, and how many products. Now we must put a condition on this field here. So you will typically put where count asterisk larger than 1. Unfortunately, this does not work. You can see the error. You can see right syntax to use near where count asterisk larger than 1. Why it doesn't work? Because you're putting a condition on something which is involved in the summary query. Whenever you put a condition, either on the function which does the summary operation or on the something which is grouped, you must use having. Let's see whether it works. Yes, it works. There is one final thing. You must remove this thing because I don't ask for it. And finally, we get the result. The next query is easy because it involves a single table. The orders in delay. So orders in delay are orders which are shipped after the required date. So select from table orders. We need order ID, comma, required date, comma, shipped date, comma, and the delay days. Delay days are calculated as the days passed between required date and shipped date. So with date diff, which you have, so first the older one, so shipped required as days. Okay, first of all, let's do the query in this way. It's always a good idea to do the query step by step. Okay, so we use it that there is also a mistake immediately. I didn't specify from which table. From orders. Let's go to new. Why does it display? Ah, okay, here. Order ID, required date, ship date, delay date. Oh, it's negative. Let's see. 1st of September, 16th of August, negative. Okay. So now, well, delay days are positive, so only the orders in delay. Let's see whether it works. Now it doesn't work because delay days is not accepted. Sometimes MySQL does this thing here. So instead of delay days, unfortunately, I have to put, for example, you may put shipped date is after required date. Or if you prefer, you can put date diff larger than 0. It's the same. Pay attention here because you have two results now. Let's see, 21 September, 23 September, so it's 2 days in delay. In fact, it's correct. Okay, we have done everything for this query here. So always pay attention because you see this result again and you wonder, why do I have the same result as before? No, it's another query. Okay, the last query, build a query that shows sorted by product name. Don't worry about the sorting, you will do it later. All the orders shipped between 1st March 1994 and 25th September 1994, also this one, don't worry, you will do it later, containing that product. So in practice, a query which shows all the orders concerning a certain product. So we need orders, order details, and products. So 3 tables. It's always the best idea is identify first the table that you need. So select product name, so from table products, product name, comma, order ID, from table orders, order ID, and order date. Okay. From, and now we must make a mega join of 3 tables. So we must join, first of all, orders with order detail. Order in join on. Let's do it like this so it's more readable. On orders order ID equal to order details dot order ID. Okay, so this is the first join. I put a big parenthesis here, and then I join this thing in join with the other table products on. This one is on order details. If you look at the graph, at the schema, it's evident which are the joining field here. Order details product ID with products product ID. Product ID equal to products product ID. Where is product ID? Here. Okay, so we have made all the joins. If you want, you can put another parenthesis here to make it clear that this big content is the joining table on which you are going to take the data from. Okay, now we must put the condition and the sorting. Condition between 1st March 1994 and 25th September 1994. So, where shipped, so where ship date, which is in orders table, shipped date between 1994 0301 and Then now the sorting. Order by, sorted by product name. So product name, ascending. Okay, it doesn't specify anything, but let's sort ascending. Oh, there is a mistake. Order ID, read the error. Don't say okay, and try to find it yourself. Read. Order ID in field list is ambiguous. In fact, this order ID, if you look, exists in order details and orders. So you must specify from which table does it come from table orders. Okay, let's run it again. Okay, let's see. It's sorted by product, order date. Yes, seems to have everything. Okay, we can save the three queries in northwind.txt. So it's .sql, but no, let's see if we can give it a name. Northwind.txt. I try to force to have .txt. Okay. An alternative could be copy, open the notepad, which is under accessories, and paste. Okay, and then save as northwind.txt. I'm overwriting. Okay. Okay. Let's check that we have everything. Northwind.txt, we check, yes, it's okay. So the first part is done. You may close everything, disconnect, cancel, close. Okay. Now let's do the second part. You can simply double click here, but much better, read carefully. Load workspace insurance.rdata. Yes, you may load it from here if you want. Otherwise, you open R. Okay. It's better to load the R commander before. Okay. It's also better to set the working directory immediately. Okay, and now you load to workspace. Okay, open. Okay, we set it also here. Okay, now we have just to give a quick look to check whether it's really what it claims to be. Yes, it's really what it claims to be. Okay, it's better that you write everything here so you can save it later. Using dataset insurance, display two appropriate graphs for vector income. Well, vector income you can look before in the printed version of the file, of the exam. Income is scale, so two appropriate graphs are evidently the scatter plot and the box plot. Sorry, not the scatter plot, the histogram and the box plot. Income. I didn't specify anything, so you just plot whatever comes out. Okay, you check that you have the command here. For me, it's the same whether you build the commands from the menus or you write them yourself with your own fingers. The box plot. And you have the box plot. The box plot appears here. We don't care now. Okay. Recode vector income into ordered vector income2 added to dataset. It means that I want income2 to be in the dataset as blah blah blah. So it's a recording. Record. Where is record? You can see when you don't study, you don't find the things. So if you study, you find the record immediately. It's here. So the variable to record is income, the new variable is income2. Record directives. So Smaller than 100. Well, I imagine that income never becomes 0, so 0, 100. Okay, this is one possibility. Okay, we will start doing this one. Okay, but even slightly better doing like this. Maybe there is a 100,5 and it will not be recorded. So let's do it. Okay, just to be sure, you can see it's written here. I want to plot it. Okay, and just to be very, very sure, levels of this thing here. Okay, so I don't have any other value. Because, first of all, it must be in the data set. Well, as you can see, if you write it like this, it's not in the data set. If you write it like this, it's in the data set. So in the data set, it is. But it's not an ordered vector. You discover it in this way. You can see income 2 is a factor, not an ordered factor. In order to make it an ordered factor, it's very easy. You just convert it to ordered. So you take it and you throw it in itself to ordered. Now let's check. You can see that now it's an ordered factor. Okay, it's a good time to save your workspace. Okay. It's also a good time to save your script, so to save everything here, because if the computer crashes, the professor is not responsible. Look up below, it's called insurance.r, so the script is saved on .r file, the workspace on R data. Now, build a new dataset insurance, add to dataset vector income 3 equal to natural logarithm of income. So this is easy. I just take it from, I don't even use the compute. I just take it here, log, okay, done. If you don't remember whether log is the natural logarithm or the decimal logarithm, just ask the help and you get the help. Oops. Well, if your browser works. Now my browser doesn't work because I am connected from home, but okay, now it should work. Okay, by default natural logarithm. Okay, build a new dataset insurance, choose selecting only cases with income smaller than 30 and use it. Subset. Okay, so just to take a quick look, you can see we don't have all the cases. Check that your current dataset is insurance true, and use it. Export dataset insurance true into a tab delimited text file insurance true.txt, blah blah blah. So we have to export it. Where is the export? Here. So write variable names, yes. Row names not required. This is forbidden. Tabs. Okay. Oh, the name is correct. Press save. Oh, now it works. If it doesn't work, sometimes mysteriously this tool doesn't work. You have to do it manually with write table command, which you know how to do it. Use dataset insurance. It means that you must change it back. Build function average to L, which takes a vector as input and calculates the average of the elements excluding the first and the last one. It's an exercise we have already done, but now there is this excluding the first and the last one. Well, the first one is the element with index 1. The last one is written here, is the element with index length of vector. So we must build a function now. It's called average to all function. It requires as input a vector. Let's call it vect. Okay, now what does the function do? It must calculate an average, so we need sum, set it equal to 0, count, set it equal to 0, and now for j in, we start from true, and we go up to length of vect minus 1. So we build a loop which starts from true and go up to the length of the vector minus 1. Inside this loop, we sum equal, as we have already done, sum plus vect of j, semicolon, count equal count plus 1, semicolon. Close the graph for the for loop. We must return something, semicolon. It's not necessary, semicolon, I think, however. Return sum divided by count. Semicolon, okay. Well, I think it's correct. You don't, this semicolon and this semicolon are not strictly needed, probably. Also, this one is not strictly needed because they don't separate anything. Let's see whether it's accepted. Okay, we want to check whether it works. Well, here it's really suggested to check whether it works on deductible. However, just to be very sure, I would like to check whether it works on a vector made of 7, 2, 3, 4, 80. If it works, the result should be 3, because 7 and 80 are not counted. Let's see. Yes, 4. Ooh, it seems that doesn't work, because 7 and 80 should be skipped. 2, 3, 4, the average is 3. Let's see what does it say in this way. So there is a mistake. We have spotted a mistake in our function. 4.5, very well. Okay, let's see. J in true to the length of the vector minus 1. Maybe a parenthesis here. Two. Okay, now it works. 3, 4, 3. Okay, it works. So we must check now on deductible. Insurance dollar deductible. Okay. Well, we don't know the result, so. Build a vector addition with numbers from 1 to 4415. So for the moment we build addition. Addition is not required to be inserted into the, no, later it's required to be inserted into the data set, so it's better to, okay, clearly tell him that addition must be 1 to 4415. Okay, for the moment we build addition. Okay, we check whether it's correct, because you never know. Yes, it's correct. We must set to NA all the numbers between 50 and 70. Well, this is easy, because between 50 and 70 are set to NA. Very easy. Let's see, check it again. You can see the numbers between 50 and 7. Okay, now return workspace insurance.rdata, so we save the workspace. Okay, text file insurance2.txt, this has already been saved before, and all the comments that you have typed into file insurance.r. So you can alternatively select everything, copy and paste into a text file, or directly from here save script as insurance.r. Okay, the exam is over, you can close everything. No, pay attention. Check that you have everything. So insurance data, insurance.txt, insurance.r, and northwind.txt. Okay, you have everything. These are the 4 files that you must give back. Okay, always have a clear idea where your file are, where are you saving, and what are you saving. It's even more important than doing the exam itself. Okay, the exam is over.